my deals with fire protection of cultural heritage buildings. And as Angelika and Ivana in the introduction speech, they recalled the fire that happened in Zagreb in 1731, pointing out why this conference is being held today. I will now, in brief, say something about what are the biggest problems in Zagreb nowadays, and what are fire safety issues that we faced on. Of course, all this can be applied to hospitals as well. So as you I have some problems. Okay, it's solved. So as you saw last year, and some of them, in fact, most of them experienced, Zagreb was hit by the biggest earthquake in last 140 years. And as a consequence, one person died and 26 people were reported to be severely injured. And this earthquake and the series of aftershocks generated widespread damage to the protected as architectural but also historical heritage buildings. And almost 500 such buildings in Old Town were partially damaged, with more than 10% of them that require additional engineering review and the decision whether to repair or demolish. And among the cultural heritage buildings, the highest damage was sustained by centuries-old churches, 30 of them categorized as cultural heritage monuments. So besides, most of the Croatian health facility buildings date from the late 19th and to early 20th century. And around 80% of those buildings were built before the introduction of seismic consideration into the building code. Most of them are masonry structures built before 1960s without any reinforced concrete elements. Those buildings are either located in the cultural heritage protected area, or they are individually protected as cultural heritage, and most of them need to be completely retrofitted. So therefore, this was the reason why this important topic for Zagreb was chosen to be highlighted in brief in just 15 minutes today, as a kind of intermezzo between lectures dealing with hospital fires. Well, although you saw photos of damaged buildings as a consequence of earthquake, for this type of buildings, speaking about heritage buildings, fire is by far the most common and destructive phenomenon, regardless of its causes. And many great fires that happened in the past and in recent history prove that. Some of them are presented in these slides, like London fire, Notre Dame fire happened 2 years ago, or fire in National Museum in Brazil. Well, this fire was declared as a national disaster, destroying over hundreds of years of collected evidence of Brazilian and South America history. And many items that were burned or damaged are irreplaceable, and there is no way to determine the monetary value for such a loss. So there is also one example of hospital in heritage building, Royal Marsden Hospital, but this hospital was famous because it was the first hospital in the world dedicated to the study and treatment of cancer. It was hit by fire in 2008. But thanks to well-trained evacuation management, all patients were evacuated in 28 minutes, although significant material loss happened. Well, generally, when we talk about historical heritage buildings, we can say that what was perceived as safe in the past may not be perceived as safe today. And some implication is that compliance means safe, and that any building that is not code compliant to the current mostly prescriptive requirements is unsafe and need to be retrofitted. So in contrast to conventional code compliant buildings where life safety is the primary and in most cases single goal of compliance, in heritage buildings other objectives are usually of equivalent importance as well. So the safety of life is still the primary goal, but the safety of the building and its contents requires development of specific non-invasive strategies that do not harm the value of monument and provide safety in case of fire. So this statement makes provision of fire safety in these buildings a rather complex task. So obviously, the approach to protect historic buildings from fire is different from other types of building. And the question arises how to use and retrofit cultural heritage buildings, taking into account today's fire safety issues. So therefore, from 2002 to 2006, there were European Coast Action number 17, which intention was to investigate all these losses and to propose measures that are needed. And during project, many publicly open documents dealing with this topic were issued. And these are just some of them presented in the title, but other can be found on the website of this cost action website of this cost action. So nowadays, Confederation of Fire Protection Association in Europe has issued a guideline at European level based on the results of the above cost action, and which deals with historic heritage building and has the content as shown on this part of the slide. So due to limited time, unfortunately, I don't have time to go through it. But I have to emphasize that this document was proposed by the Slovenian National Fire Protection Association, whose representatives are with us today and can say more about it. Now I will say something about Nfpa Code for Protection of Historical Buildings, because the basic for that is to preserve the original qualities of character of a building structure, site, or environment. And this code requires two approaches. It is prescriptive approach, but these approach are permitted to be modified, and in that sense automatic or manual suppression systems are permitted to be considered as compensatory features. And the other is performance-based options, which needs demonstration of performance in numerous design fire scenarios. Considering the first one, there are different classifications, but these are some active fire protection systems that can be applied in this cultural heritage building as well. And today, most of them have features that are highly visible and can fit into all these buildings. These are some examples of fire alarm system or sprinklers, wells, and so on, or automatic mist systems that are hardly visible. Considering the second one, a performance-based approach of fire engineering, We all know, because we are dealing with fire safety engineering, what are new methods for that. But I have to emphasize one advantage is that these specific measures are based on the actual characteristics of the building and the people using it, rather than a general concept of prescriptive approach. And it is important because all heritage buildings is unique, so we can adapt needs of fire safety to certain buildings. But disadvantage is that this approach is multidisciplinary, and necessary education of all stakeholders in the project design and validation process have to be obtained. Today in Croatia, we have just one place where these new methods are learned. So there are some examples of using this fire engineering application. And in this slide, you can see simulation of fire and smoke development in one building, where final results is temperature, smoke velocity, smoke concentration, field, and so on. The next one application is that we use fire engineering principles for the calculation of the resistance and response of the structure to fire, showing the deformation of the structure. And the last one, which is very often problem in historic buildings, is problems with evacuation routes, especially with the dimensions, with the length. So these models offers that in particular situation you can calculate, for instance, time to be provided for evacuation of people, or how much place. For instance, in this slide you can see hospital or evacuation in dormitory when people are placed from one compartment to the other compartment. And as the last part of my presentation, I will show you just example of Shakespeare Globe Theatre in London. This, as you know, it was built in 16th century, and it was burned to ground in 17th centuries. So it was originally made of wood and with a straw cover, and initial capacity was about 3,000 persons. So it was renovated in 1994, but before it was renovated, extensive research was conducted to see how to renovate this theater, but some features to stay, like combustible materials like straw and timber buildings. So also CFD modeling and evacuation modeling was employed, and as final result is today's theater that is used almost like initial one. So wooden elements stayed, and during performances candles are used. So initially, as you know, during Shakespeare's dramas, candles were used for lighting, and today it is also used, but audience is decreased to 1,060. It is just half of initial one. As I said at the beginning, it was 3,000. So this is fantastic example how modern technologies and how modern fire engineering help that this theater was rebuilt as initial one. So at end, I will conclude briefly just in 4 sentences, 3 or 4 sentences I already said. Well, in case of heritage buildings, fire safety objectives include life safety, but must also include adequate heritage protection. So in this, for this building, it is important to understand that safety is not achieved by code compliance alone, and that code compliance is not synonymous with safety. So many heritage buildings have features or have elements that make them inherently safe, although they do not comply with current codes. And good solutions for heritage buildings include analysis and application of active fire protection methods and fire safety engineering approach. So thank you all for your kind attention. And for this slide, I would also like to acknowledge my co-authors, Mr. Milan Zalarević and Miodrag Drakulić, which are also lecturers on our fire safety engineering and our faculty.